Okay, we'll start now. Hello, everyone, and welcome to the 125th free webinar titled Scale Control and Flow Assurance, presented by instructor Engineer Muhammad Askar. Engineer Muhammad is an experienced well integrity engineer with over 13 years of working experience in the oil industry. He has a diverse range of expertise in various petroleum engineering roles as a company representative or consultant, including artificial lift, well integrity, production technology, well completion, well servicing, well intervention, scale management, and flow assurance. Uh, this is just a small brief about Engineer Muhammad's biography. I'll let him introduce himself fully details later. But before we start our session, I'll just make a small presentation about OPA upcoming service and plans. We will have a scale management and flow assurance live course that starts next Saturday, 28th March. You can scan this QR code to register. Our courses, you will get lifetime access for course recordings. You will join our ambassadors loyalty program for extra discounts and offers. Not to mention that you will validate or verify your certificate through our online credential verification system on our website. And you will also join our WhatsApp group if you have any technical questions. Even after the course ends, you can ask any question there, and the instructor will be able to answer them. Here in OPA, we have conducted more than 60 or 70 courses in various disciplines in oil and gas, like reservoir engineering, production technology, rig and rigless operations, G&G, and safety. You can also scan this QR code to register or check our list of recorded courses. Here is also one of our services, which is OPA App Store, where you can find affordable alternatives for software to save your time and money. It's only made for specific tasks. You can also scan this store through our website. And here's one of our best services, which is mentorship. It's a one-to-one mentoring sessions by experienced mentors. It's like a tailored program based on your needs. You can request explain the know-how of a software, guiding on personal data, professional guiding for PhD and master, helping undergrad students in their project. We have completed more than 50 mentorship program with more than 1,000 learning hours, and the mentees were from more than 10 different countries. You can also scan this QR code to register in our mentorship program. And finally, here's our website, opacourses.com, where you can access everything through our services, with whether you are applying for online, uh, online live or recorded course, uh, downloading any of our app store, um, whether applying for mentorship program, enrolling in our free webinars, everything you can access it through our website. So make sure you pay it a visit. And how to be an OPA ambassador? To get there are two tracks to join our OPA ambassadors community. Take one or more courses with us, or just take a mentorship program. So what will you get from being an OPA ambassador? You will get discounts on all courses in the future and group discounts when you invite your colleagues. Thank you for listening, and now it's time for our session. Engineer Muhammad, you can start your presentation now. And for your information, Engineer Muhammad had just sent a pre-webinar assessment. Please visit it, visit the link and make the assessment if you Okay, we can see the screen now, Njumha.
Okay, good. Can you hear me now?
Yes, we can hear you.
Okay, thank you for the introduction, and it's an honor to be here with you in this webinar, inshallah. It will be 1 hour or more. I think it will be more, inshallah. But before making the webinar, I should assist the people who are attending now the course to see the tuning of the course itself. It will be advanced or basics, and to know some guidelines before the course itself. And after the course, we'll visit these questions again. You can scan this QR code, or you can open the link from the chat box, and we can join the webinar with the assessment. It's like a simple website, and you can choose answer after this in the next slide. We have now 7 joined the assessment. Okay, the first one, what's your country? And what's your profession? If you are a student, you can just write your department name, maybe mining, refining, petroleum engineering, chemical engineering. And I can wait here for just 2 minutes for the other guys to attend with us this assessment. You can open the link from that chat box. Just click it, and you will be directed to the assessment, or you can scan the code that we showed earlier, or you can just open your browser and type menti.com and use this number to be directed to the assessment. We have 25 people in the webinar itself, and in the assessment we have 14, but only 9 just have submitted their answers. So just 30 seconds, and I will move to the next slide to save your time. Okay, for our first question, hydrate plugs. Do you know about hydrate? Something solid that we can see in the flow lines. These hydrate plugs need water, hydrocarbon gas, and low pressure to form and restrict the pipeline itself. Do you agree, or you don't agree, or you may agree with some remarks, or you don't have any idea? So just select the last answer. It's called no comment. You don't know. Just one minute for every question to give you some time to think about the answer and select your answer. Then we can move to other ones. We'll move to the next question, which is about asphaltene. Asphaltene is a heavy soluble hydrocarbon compound. Do you agree or don't agree, or you don't know? My intention about this assessment to be before the webinar is to give you some knowledge about the session itself and then make you concentrate on the answers of these questions and assess for me it will assessing your knowledge to give you the level of the knowledge that is suitable for you. And after the webinar, after the course itself, we can revise the answers again to see what knowledge you have gained from the course itself. So just 10 seconds to move to the next question. The third question about paraffin. We use paraffin dispersant and it works by depressing the wax appearance temperature, which is called WAT, wax appearance temperature. The next one is about insulation. With insulation for the pipeline should be placed between two pipes for efficient thermal management. With insulation. Okay, for question number 5, carbonate scales will deposit when temperature decreases. Carbonate scales. If I didn't mention the information about the question during the course and you found that I already bypassed this part, you can ask me about the question itself. So you will be concentrating with me during the session, right? just 10 seconds to move to the next question. Number 6, scale deposition affinity is not affected by the application of any hydrate chemical inhibitor. It's about the probability and the tendency to have scale deposition. Number 7, gas lift completions promote emulsion formation and scale deposition problems for gas lift completions. The last question is about smart and intelligent pigs. Pigging, you send a pig inside the flow line. This smart pig can inspect the pipeline wall thickness for corrosion monitoring purposes. Do you agree or no, or you don't know about this information? If you want to contribute and ask me during the session, it's okay. You can open your mic during the whole session, and at any time you can stop me and ask me. Okay? I see some notes and some comments is going down, but during the session, it's okay. You can ask me at any time. This is the last one, so I will now shift to the presentation itself. Do you see the PowerPoint presentation right now?
Yes, we can see it.
It's better to make it on this
Yeah,
presentation
as a
view.
slideshow, yes.
Good. Okay, we'll start about, we are introducing flow assurance. What is flow assurance itself? What is the definition? What is the challenges? What is the sources? And what is the scope of a flow assurance? Then we'll discuss the most important ones will be hydrate, paraffin, and asphaltene, and the scale and the corrosion. There are other types of flow assurance issues, but we will not mention them in details like this one. And we'll end our webinar, inshallah, by the remedial actions of flow assurance. So what are we doing now in the oil industry? We are producing oil and gas. This is the main target for us. But when you produce oil and gas, it's mandatory that you will produce some gases, maybe H2S and the CO2, it's called sour gases. And you can also produce some water. This water may be in the formation itself, the formation water, or you are injecting this water in some injection wells to support and to sweep the oil and make flooding. So you will produce many fluids, gases, liquids, oil, and water, and you can produce some solids. These solids may be scales, we will talk about it, and maybe some sand from the formation itself. But my target is to produce the hydrocarbon and it reaching the sale point efficiently, safely, with low cost, and without damaging the environment. So if we can see here, we have many layers of formations, and I produce the oil by any artificial method or naturally. Then I direct this production to the facility for separation and for consumption and for transportation and distribution to the consumer. But my point is to produce it safely without any problem, without affecting the integrity of the pipeline, without affecting the integrity of the well itself. So flow assurance means that I need to produce the hydrocarbon and reach its target without any problem. This problem is maybe restricting the flow itself. My target is to maximize the flow, optimize the flow, produce the well as much as I can without affecting the resources, without affecting the environment. So I need to remove any obstruction inside the flow line and inside the well itself. The second part is to prevent any leakage to the environment. This leak may affect the environment, affect the people around it. So I need to use many disciplines like chemistry, like production technology, like production engineering, like many other disciplines that can manage to make this mission successful and to take the oil and the gas from underground till the source, till the separation and distribution efficiently and safely. Okay. So the most common types for flow assurance is that I have some blockage inside the flow line itself or inside the well downhole. This blockage may be scales, which is the main topic today. These scales may be calcium carbonate, barium sulfate, zinc sulfide. We have many types of mineral scales, and also have some solid deposition. It's called paraffin and asphaltene. You can see the pointer right now, right? Is your screen is good?
Yes, we can
Yes,
see.
yes, we can see it.
Good, great. So flow assurance, we talked that we don't need to restrict the production. We need to maximize the production rate and make it efficient production. So I need to remove any restriction inside the flow line itself, which may be scales, paraffin and asphaltene. We will see the difference between paraffin and asphaltene, and maybe hydrates. Hydrates is a combination between gas and water, as you saw in the pre-course assessment. And also emulsion and foam. There are some types of that. You have a mixture. Emulsion means a mixture of oil and water, maybe emulsion oil in water or water in oil, but you have like a colloidal state between the two regimes, between the two phases, which have high viscosity. So have many pressure losses in the flow line. Foam means that you have a liquid and the gas, and you are having a mixture, and this mixture also making additional pressure losses. For the integrity, corrosion means that you are interacting with the metal parts of the flow line and the pipeline and any metallic parts like the Christmas tree, the tubing, the casing, and affecting their integrity chemically. But erosion is mechanical, that you are producing some sand due to the impact of these sand particles. It can affect the thickness of the flow line and make it lower, and after some time you can see some leakage to the environment. Other parts of flow assurance, like slugging. If you have a flow line, this flow line is not like a ruler, it's like very straight. No, it have some go up and down. So you have some slugging phenomena in your processing facility, that your separator is receiving a huge amount of liquid and sometimes it go down, then a huge amount of liquid, then go down. This surging will affect the performance of the production facility and reduce the total production rate of the facility itself. And for the low temperatures, it will affect the viscosity of the fluid. It will get higher and introduce additional pressure losses, and it will introduce hydrate and asphaltene and paraffin deposition. So all of these items are the main criteria of flow assurance that you should care about, and you should face these challenges and solve them before happening, or repair them after happening or remove them after happening. It's AI generated picture to show that we have some gas hydrates, wax and paraffin and asphaltene, and sludge. Sludge is a type of hydrocarbon deposit that when you make some stimulation job, you pump acids like HCl acid, and this acid will interact with some crude oils, asphalt crude oils, and produce the sludge. So it's type of formation damage and flow assurance issues. And also other types of organic scales that may be carbonates, sulfates, sulfides, many types. And the other additional ones of flow assurance is slugging and flow instability like emulsion and other types of foaming. For this picture, we have a subsea wells, subsea field. We have Christmas tree on just the seabed. This era makes flow assurance important, especially like from 20 years from now, is that we are producing many oil and many gas from subsea wells. Subsea wells means that you have a long subsea lines that encounter a very high cooling, so the temperature will be dropped. And when you drop temperature, you can see some scales, some paraffin, some asphaltene, some hydrate deposition. So they cared mainly about flow assurance, and it's like a job now, a profession now, to be a flow assurance engineer that care about the process itself, that care about the problems to prevent them from happening. Okay. So for the single flow line, I may have all the issues at the same flow line. I may see some scales, hydrate or paraffin deposition, but for the subsea pipelines, I may have some corrosion inside and outside, right? Because you are producing oil with water from inside the flow line itself. And for outside the pipeline, you are seeing the seawater. So you can use some coating for the pipeline for outside to prevent the seawater interaction to the pipeline and prevent any corrosion, any outside or outer corrosion. Okay. For us as a petroleum engineer, what is my target here to care about? As a petroleum engineer, I care about the reservoir. I have hydrocarbon inside it, and I will start with the reservoir pressure. And when the oil or gas get to flow from the boundary to reaching the sandy face, it will have some losses. These losses depend on the permeability of the formation itself and the viscosity of the fluid, Darcy law, and some other issues like the pressure differential, like the length, the area. Okay, and if you have some skin means that you have some scales or damage inside the formation itself. So I have pressure losses here. Then you will have some pressure losses through the completion itself. The completion means if you are producing from open hole, it means low pressure losses. But if you are producing from sand screens and gravel back, it will be high pressure losses, right? Then I will have the bottom hole flowing pressure. Then I will start to flow from down of the well till reaching the wellhead. I will have some losses during it. The most main part of losses during the well itself, it will be hydrostatic head. It's like 85% of the pressure losses, and the friction losses is only 15%. But I should care about restrictions inside the well, because any restriction inside the well will affect the production rate and will affect the accessibility to the well. If the rate is good for you and it's economical to be produced and you are okay with this production rate, but if you want to make any well intervention job, well intervention means that you get inside the well to make some repairing, some perforation, some logging, some setting plugs or pumping cement or cleaning, any job that you should get inside the well, but you have restriction inside the well. This restriction will affect your accessibility and your ability to reach the bottom. So I need to care about the losses here and care about the ID, the internal diameter of the tubing itself. Then to reaching the separator, I will have some losses during the flow itself. This losses will be for the flow line. It will be mainly for restrictions if you have a production choke, if you have some scales, if you have some elbows and some bad design for the pipeline. At the end, you will have the IPR, inflow performance relationship, which is the relationship between pressure and rate inside the formation. And you will have a vertical rift performance, which is the relationship between bottom hole flowing pressure and the rate inside the tubing, the production completion. And the intersection will be the production capability of the well to deliver this flow rate. Okay, so it's defining the oil production rate. We started from pressure losses, and we are now ending till the capability of the oil to produce. For this one, it's the same schematic with some additional details that I may have some pressure losses in the restriction downhole in the safety valve across the surface choke. So it's not only about the scale deposition or paraffin deposition, the flow assurance issues, it's about your design of the tubing itself and the flow line itself. When you introduce many additional restrictions, it will promote pressure losses and make reduction for the flow rate capability of your system itself. Okay. So we agreed that we are producing oil or gas, but this oil may be accompanied by water or gas, right? In the reservoir, we have gas layer due to the low density of it. Then we have oil, then we have water. I can use this water by injecting water inside it to increase the pressure of the reservoir and increase production. But at some time, I can see some water breakthrough, means that the water is getting through the perforation and I can now produce water with oil. When I produce water and oil at the surface, due to low pressure, the gas will get liberated again from the oil. So I will see in the pipeline, this is a horizontal pipeline. We'll see separated phases of gas and oil and water. But do you see that it will be a pure gas and a pure oil and a pure water? No, it will be gas with some droplets inside it, maybe dispersed oil or dispersed water. But you should have some mist flow of liquids inside this gas. Then for the oil, we have some water inside it, maybe in the emulsion phase, or maybe just droplets. And in the water also, we have some oil and the gas, a small amount of gas, and also solids. I can see some scales or sand in this system, but it will be at the low part of the flow line, mainly in the water phase. Here we have a single phase, which is oil, and we are producing it. The oil is moving from the high pressure to the low pressure. When it moves from the high pressure to the low pressure, gases will get outside from solution. So I'll have some gas bubbles. Then these bubbles will get bigger. Then it may be mainly at the end, it will be gas flow with mist particles inside it. So the fluids and the phases will be changing from location to other location, from pressure to other pressure, and it will depend on the reservoir and depend on the main fluid you are producing. But you should make sure that from the beginning, you will produce many fluids, so it will be a multi-phase flow, and you should care about the interaction between these phases, because oil and water may promote some emulsion, right? Oil itself may deposit paraffin and asphaltene. Water itself may deposit scales. Gas with water may deposit or form hydrate, right? Gas and the liquid may form foam. So all of these issues is flow assurance challenges. And also the water, if it has a low pH and a high salinity, it will be corrosive water, and it can make some corrosion for the pipeline. What about gas? I told you at the beginning that this gas may have some H2S, hydrogen sulfide, and the carbon dioxide, CO2 gases, which is sour gases. The sour gases, when dissolved inside the water, make carbonic acid, and this acid can dissolve or interact with the metallic parts, and also have some phenomena called sulfide distress corrosion cracking, that H2S can make a damage and the corrosion for the pipeline itself, for the metallic parts, especially for the compression equipment for the turbines due to the high pressure. So all these fluids can make some flow assurance issues and the challenges that I should care about and prevent from happening. Do you have any question till now, or is it everything is clear for you? Okay, I will assume that everything is clear. And I told you at the beginning, if you have any questions, just open the mic and ask me directly without the need to write a box. And I will check the chat box. We have no questions till now. Okay. Do you remember this graph? Guys, it's a phase behavior of pressure and temperature. From the beginning, if have a single material, single component, single gas, the pressure and temperature relationship will be a single line. that you will change from the liquid phase to the vapor phase or vice versa instantly without having two phases in the system at the same time. But due to that the crude oil itself, which may be oil or gas in the reservoir, have many components. These components is like thousands, okay, starting from methane, ethane, propan, butane, and it will be complex ones like asphaltene and long chain paraffin. But due to the density itself or the oil state, I may have some black oil. Okay, this black oil, it's in the liquid phase in the reservoir, but after production, I will reduce the pressure, so I will get inside the two-phase region, right? The two-phase region that I will have multi-phase flow. For the volatile oil, it's the same also, but the oil is much lighter. For the gas, I will maybe have some dry gas, that the gas is in the gas phase in the bottom in the reservoir, and in the gas phase at the surface itself and the separation unit, without having any gas condensate. But for wet gas or gas condensate reservoirs, for the separation point, I will see some liquid. And for the gas condensate or retrograde crude oil, you will have some retrograde or condensation inside the reservoir. Some companies report that they are producing gas, but after some time of production, the gas production rate is reducing down, is getting down, because they have liquid dropout inside the reservoir, and this liquid inside the formation is like a damage. So they need to repressurize again the reservoir or remove this liquids from the flow line, from the formation itself, or just lift the liquid from the well. You have liquid loading that during production, due to the high density of the liquid, it get dropped inside the well and it will accumulate at the bottom. And after some time, you need to lift this liquid, maybe by plunger, by foam, by gas injection, by velocity string, by any method, just to remove the back pressure on the well and remove the accumulated liquid and restore the high rate of production of this gas of the well again. So from the beginning, from flow assurance, you should start by knowing the crude oil you are dealing with. If you are dealing with the high density crude oil, high viscosity crude oil, okay, for the high density crude oil, you have some asphaltene inside it. You send the sample, take a sample from the crude oil, send it to the chemical department to see the asphaltene and the paraffin content of the fluid itself, and measure the wax appearance temperature and the pour point temperature of the crude oil to determine which temperature you need to keep your flow line above it, because below this temperature you will see some accumulation and deposition of paraffin and asphaltene. We have a comment in the chat box about the retrograde gas condensate reservoir or gas condensate crude oil. It's the same type. You have gas condensate fluid or retrograde fluid that you see the liquid again in the two phase, and when you reduce pressure more, you get out from the two phase region. We'll start by the gas phase, and when you reduce pressure at the same temperature of the reservoir, we'll have some liquid drop out inside the formation, and with more depletion and more production, the pressure will be reduced and the liquid, condensed liquid, will be evaporized again. So we'll return it again to the gas phase. So it's called retrograde, and it's the same one of gas condensate reservoir fluid. As a flow assurance engineer, don't see the phase behavior as you saw before in the previous slide. We have some comment. Okay, thank you. Don't see the phase behavior as gas and the liquid and two phase. He cares about the flow assurance issues, as we talked about. He cares that when he reduce pressure, will have some asphaltene. When he reduce temperature, will have some wax. When he have some gas and water and high pressure and low temperature, he will see some gas hydrates. In the question, in the assessment, there is something called gas hydrate can be deposited due to having hydrocarbon gas, which is mainly methane, and we have water, and we have low pressure. No, it's wrong. I should have high pressure and low temperature. to make the liquids condense with each other and to make them interact and have a trapment for the gas inside the water. We'll see some pictures of hydrate, inshallah. So for flow assurance, we have many items to deal with. We should start by the reservoir fluids. You should take a sample from the reservoir, the downhole sample. It's preferred to be downhole sample, not surface sample, during the exploitation of the first production, maybe during the drilling phase. Drill stem test, but we have like RMT, reservoir monitoring tool, and the MDT, modular dynamic tester, and RST, just to take samples downhole from the well itself against the perforation, and keep it under the pressure and temperature of the reservoir, and take it to the surface for more analysis to see what components you have. If it is water, what minerals you have in the water. If it is oil, what is the phase behavior of this oil, and what is the asphaltene and paraffin content of it. So we'll start from taking a sample from the fluid itself. Then we will study the sample and to see what if I have some problems inside the production itself. What is the viscosity of the fluids? What is the modeling? If I have some slugging or surging or no. If I have some slugging, I use slug catcher or choking, smart choking or intelligent choking to prevent slugging. Okay. And for heat transfer, we talked that when you reduce the temperature, mainly for subsea applications and subsea flow lines, we'll see some flow assurance issues, which may be hydrate, scales, paraffin, and asphaltene deposition. So I need to insulate the flow line to prevent the heat losses. MashaAllah, thank you. So we coat the flow line and have some insulation. This insulation to prevent the heat losses. We have many types of heat insulation material, maybe polyurethane or polypropylene, or it's type of foam. And we have some wet insulation. I will talk about it just as in a single slide, and dry insulation and bundle insulation. So my target is to prevent the heat losses to the atmosphere. But heating means that I introduce more heat, external heat to the fluid itself. Heating means that I use electricity, maybe electric heating system or a hot fluid system that you can just circulate hot fluid around the flow line to increase the temperature of the flow line and prevent any deposition of other issues, or just use electric cable just around the flow line. This electric cable is called electric tracing cable. And when you put electricity in this cable, it's like the heater we have in the household applications. It will increase the temperature of the flow line and prevent any blockage inside the flow line itself. So we are now talking about heat, about temperature. But the main challenges, we talked that the flow restriction may be emulsion and foaming and surging also that affect the pressure losses, and the blockages that we have a physical component inside the flow line or inside the well, maybe hydrate, wax, asphaltene, and scale, and sand. It's like accumulation of sand production. Naphthenate is mainly a component that it's like naphthenic crude oil that get interacted with calcium and magnesium and cations to produce this like a heavy component or emulsion component, but it's mainly for surface applications. But it's also a flow assurance issue that you can see inside the separators and the flow lines, and that can affect your production. Integrity losses means that it will affect the thickness of the flow line, affect the integrity and the safety of the flow line and the well by corrosion, erosion, bacteria. What types of bacteria we are dealing with? Something called sulfate-reducing bacteria. Bacteria that can eat the SO4, sulfate ions in the injection water, and some hydrocarbon components from the crude oil, and they produce H2S. So it's producing H2S, hydrogen sulfide, which is corrosive to the environment. This bacteria is anaerobic, that can't need any oxygen to grow and to make colonies. And there are some other types of bacteria like iron-reducing bacteria and acid-reducing bacteria that can make some corrosion for the metallic parts. Souring means that you have bacteria inside the reservoir and the H2S value is not the original value of the reservoir, and you have increase in the H2S value. We saw this in several fields in Egypt and outside Egypt. When you inject especially seawater without removing the sulfate from the seawater, If you want to remove the sulfate, it's called desulfation, that you remove the nutrition, the food for the bacteria from the water and inject it. For system operability, you should use recommended practice for operation and for production, especially for shutdown and startup, because when you have some shutdown for the system, it means you have low temperature. This low temperature, as we talked, it will promote scale deposition and paraffin deposition, and it can affect your facility. So at this startup procedure, you should put some like hydrate inhibitor and scale inhibitor to prevent the solid deposition and prevent any problem, because your system is down and the temperature is down now. But during production, you are producing hot fluids from underground, and these fluids have high temperature, as we talked, and you are now producing the safe zone that no deposition can be encountered or so inside the well or inside the flow lines. To evaluate the well performance and evaluate your capability to fight and prevent the flow assurance issues, you should test the well. You should test the well and see that this well is producing with 5,000 barrels per day. After 2 months, you tested it and found it's producing with 4,000 barrel oil per day. So you have losses for a short time. So what is the reason? You will start by the easy ones, which is mechanical components that some valves are maybe closed, or maybe the ECP pump you are using have bad performance, or you have some problem in the gas lift valves, or you have any mechanical problems that can be solved easily. But you may have some other causes. These causes may be scale deposition, maybe inside the well, maybe inside the formation. You may have some foaming or emulsion that have additional pressure losses that affect your performance. So you should evaluate the well performance and assess it to see the root cause problem and solve it and prevent it from being bigger. For solids, I should remove the solids because solids can make erosion, as we talked about this point, and also solids promote emulsion and also can fill the separator and make the separator capacity is low, and it will also reduce your production capability. Okay. Pigging is a type of production operation that you send some mechanical component inside the flow line to remove any scales or any paraffin or any sand. Also for any water accumulation for the low side of the flow line, and to clean it to manage production and increase production through this flow line. We have a question: would you recommend geothermal energy for heating purposes? It's okay, but you can't control it. You can't control the geothermal energy. So we use man-made system that may be electric systems or hot fluid. But some companies use the crude oil that they are producing from some high pressure, high temperature wells to be circulated around the flow lines to keep the temperature hot and make the temperature higher. But it depends in the application and the experience of the company itself, and it will depend on the facility that they have. Okay, material selection is a part of corrosion. So if you are producing H2S and CO2 and some corrosive fluids, you should replace the carbon steel, which is an ordinary steel one, with a corrosion resistance alloy. If you remember, or if you know that we have alloy means that we put some components with the iron. We have Fe, which is the iron, and we put carbon with it to be low carbon steel, which is the least and the cheapest steel we have in the flow lines and the tubing. We can also add some other items, other element, which maybe chrome, vanadium, molybdenum, maybe nickel, maybe aluminum, maybe silicon, maybe other minerals that get inside the alloy itself and enhance its properties. Enhance the corrosion property, enhance the elasticity, make it more ductile, enhance the stiffness of it, the strength of it. But mainly we talk here about the material selection for corrosion. So I need to use a corrosion resistance alloy to prevent the corrosion issue, which is a flow assurance one. So it's here open discussion with you. What are the sources of flow assurance? You now know that we have problems of flow assurance. So what are the sources of these problems? can you tell me some thoughts about it? You can open the mic now. I just will wait for your answers and your contributions. Hello, guys. Can we have some volunteers?
Sorry, can you repeat the question?
Yeah, what do you think, which is the sources of flow assurance? You know, the problems of flow assurance is scales, paraffin, asphaltene, corrosion,
Yeah, I mean,
erosion.
yeah, I think the pressure change, temperature change, all this will be a source of, yeah.
Good, mashallah. So pressure change means that you are producing the reservoir without any pressure support, right?
Correct.
Good. And other guys, other attendees, do you have any thoughts about this one?
Also, I want to say like water producing, like will be source of hydration.
MashaAllah. So when you produce water, no, our target is not to produce water. We are producing oil or gas, but this water may be due to formation water breakthrough or water injection, fingering. And we have some water with the fluid itself. And at the surface, we have some emulsion, agitation between the oil and the water. And we have some problems or maybe scales due to water or corrosion. Good.
Engineer,
Other-
it may be
Okay.
chemical reactions or solid deposition, temperature and pressure changes.
Good. I will give you some hint about my answer, my answer that I need to tell me. Do you think that drilling can affect flow assurance? I will answer the question. During drilling, we use mud, drilling mud. You know this fluid? This fluid have some chemicals inside it. It will be some mainly water if you are not drilling the base zone, and it will have some chemicals inside it. This chemical increase the viscosity, make it like a gel to support and lift the cuttings. And these chemicals may get inside the formation itself and it changes the wettability. If you know the wettability, my formation need to be water wet, that it can stick to the water and I can produce oil. But due to these chemicals, maybe surfactant or mutual solvent, they can affect and change the wettability to make my formation oil wet. So the production rate will be reduced. I told you at the beginning that flow assurance means I need to produce the well, the system itself efficiently with high production rate, economically with the low cost, and without affecting the environment, without any leakage to the environment. Right? For production, my question for you, for production is the problem. You told me, right, that production promote pressure losses and pressure reduction, and also temperature reduction. You are producing from downhole and during the pass from down till the surface and through the surface pipelines, you'll have temperature reduction, right?
Yeah.
Good. Do you have any other thoughts about what is the sources of flow assurance? Any other new guys?
Hello, sir. Like wettability alteration,
Good.
the
Due to
water
some
cooling
chemical,
issues,
right? Water cooling and water fingering. Good.
an excessive sand production.
MashaAllah. Some reservoirs are unconsolidated, so after production, they produce sand, solids. This sand makes some erosion for the flow line and for the tubing, and they may promote emulsion, right? And also, what do you think about injection, water injection itself in the injector well? When I inject water in the well itself, can I introduce some damage to the injector itself?
Yes, yes. Sometimes if we inject a water that doesn't contain a lot of ions like chlorure or sulfates, that make the environment in the reservoir some basic environment, and that favorite shale swelling. So the cement in the reservoir, like chlorate, kaolinite, or elite.
You talked about a good point. It's called clay swelling. That when you inject water inside the well and you have some clay minerals in the formation, this clay
Yes.
gets some swelling and they can get bigger and close the permeability and they make damage and reduce the injectivity of the well itself. It's a good point. And also, you hinted about the quality of the water itself. You should make sure that the water should be good quality, will not affect the formation, will not make some plugging, will not make any scale deposition, and also it should not contain any oil. Do you know about produced water reinjection? BWRI, produced water reinjection. When you take the production water and inject it again in the injector wells. So you should process the production water and remove any solids from it, remove any chemicals, remove any oil, because when you inject them again inside the injector wells, it will damage the formation and reduce the injectivity with time. Okay?
Yes.
Good. So these are the issues and the root causes of flow assurance. We talked about drilling and completion. I can introduce some foreign fluids to the formation, and they may change the wettability. They may have introduced some solids. If you know the mud filtrate and the mud filter cake, these are solids and fluids that get inside the formation and affect the permeability. And during production, as you stated, I have pressure depletion and pressure losses, and some gases will get from the fluid itself, and it will have some change in the pH, and it's like gas stripping, and some fluids can deposit some asphaltene due to pressure reduction and temperature reduction and heat losses, mainly for subsea applications and offshore wells. You have a big temperature decline, which will promote scale deposition and paraffin deposition. We talked about the restriction and the completion inside the downhole completion. They introduce more pressure reductions, more restriction and choking. This one reduce the pressure and make some disturbance for the fluid and may promote some deposition. Okay. And we should design the surface facilities and downhole completion efficiently to prevent any additional pressure losses, to reserve the heat, to reserve the pressure, and to inject the chemicals. We have raised hand, Zakaria. It's okay?
Yes, sir, just a question.
Okay, my friend.
Can we consider the surfactant retention as a source of flow assurance?
It will promote formation damage. Surfactant can adhere to the rock itself and can make some oil adhere to the rock. So it will change the wettability and it introduce formation damage, means that the production rate will be reduced. And it's also type of flow assurance. We talked that the objective of flow assurance to maximize production and to be the lowest cost and the safest option to the company and to the environment. So it's okay to consider it as a type of flow assurance issue and damage to the formation, but not a big one.
Thanks.
Not a big one like scales, paraffin, asphaltene, but it should be considered also.
Okay, thank you.
Thank you, my friend. We talked that we produce water with oil. I should remove the water. Okay. Ibrahim, can you talk about your question? Can't we make a certain amount of this surfactant to avoid this damage? For formations, they should be water wet. That the fluid, the phase that is sticking to the formation grains should be water. And the fluid that is going through the passes of flow, the main flow passes or highway flow, it may be oil, should be oil. So if the asphaltene is deposited to the formation, so have some coating to the grain itself. It's coated by asphaltene. So this asphaltene is hydrocarbon, so it may change the wettability. And some oil-based drill fluids, they use surfactant and solvent, some surfactant to make the fluid lift the cuttings, to make the oil-based drilling fluid lift the cutting. So when you figure out that you have changed the wettability of the formation, you should restore it again by washing the grain, by other types of mutual solvent and surfactant, maybe by diesel and xylene and hydrocarbons, to clean the grains itself and restore its wettability. Because surfactant may have different charges, negative charge or positive charge, depend on the formation itself. Okay, for water itself, I should remove the water from the oil to prevent any emulsion formation, and remove it from the gas to prevent any hydrate formation. If you know about the glycol unit, it's a unit that can strip and remove the water from the gas stream. Okay. For artificial lift, some pumps can make agitation, and the gas lift also make agitation and severe mixing for the fluids. So they promote emulsion. But gas lift means that we inject a big amount of gas through a small valve, and it will expand very fast due to the Joule-Thomson effect. It will introduce more cooling to the well itself. This cooling will promote scale deposition. Okay, this is for artificial lift. Stimulation fluids, when you inject some acids, these acids may interact with asphaltic crude oils and produce sludge, which is a type of formation damage. And also for injection operation, we talked that the injection water should have good quality to prevent the formation damage to the injector. And any introduction to fluids to the wellbore should be used with corrosion inhibitor, scale inhibitor, and anti-clay swelling agent, as you mentioned, clay swelling inhibitor, and any other additives to prevent the corrosion, like corrosion inhibitor, oxygen scavenger, and prevent the interaction with the fluid itself, and prevent the deposition inside the formation, prevent any formation damage. So when I care about flow assurance, I will have some benefits. These benefits will be maximizing the production, saving money, and protecting the environment, and reducing the risk if you have some corrosion and you have some leak to the environment, and also preventing the shutdown times for the plant or the process facilities, and it will be production optimization. So we have many benefits of maintaining flow assurance. So this is a question for you. What is the starting point to apply flow assurance issues or flow assurance management? My opinion is I will start it from production. I am now producing oil and gas, so I will care about flow assurance and to see what issues I will face inside the process facilities itself. So my answer, I will start flow assurance from the production phase. Do you agree with me or no? Hello, guys. Do you have any thoughts about my opinion?
For me, it's development actually.
Here, right? What is the reason? Okay, for other guys, other participants, do you have any thoughts about what is the starting time to care about flow assurance?
During production or development?
Good. So you agree with me and also with Rawa, I think. And Ibrahim is mentioning in the comments because within flow we can get the flow assurance, detect the assurance. Okay, and you can see the phenomena. I need some other guys. What do you think? We have 27 people in the webinar. It's okay to say what you think. It may be wrong or right. I said my opinion. I will start flow assurance from production. Is it right or wrong?
Yes, it's right.
right. You agree with me. Why? Because I'm the instructor, or I'm saying the right statement?
Sir, if we make a flashback about the main sources of flow assurance, we can say that it can touch all the steps of production.
Okay, so we care about flow assurance when we start production.
Yes, but sometimes we can face it in the discovery phase, perhaps, like
MashaAllah,
a bad
MashaAllah,
a bad choice of drilling fluid
MashaAllah, MashaAllah.
or a bad
This is
design of completion.
good, MashaAllah, MashaAllah. This is the answer I'm waiting for. My answer is to care about flow assurance from production. It's very wrong answer. I told you from the beginning that I take a sample from the reservoir fluid under the reservoir conditions and make assessment for it to see what is the conditions or problems that I will see during production. And you mentioned that when I see the fluid, I will design the completion phase, the completion string to optimize and prevent this problem, maybe by downhole control injection, maybe by chemical injection at the surface. So from seeing the hydrocarbon, from seeing the reserve, you should take samples. If you remember this slide, in the holistic approach of flow assurance, you should care about sampling and fluid analysis. So it will be done in the discovery phase, as you mentioned. When I say a discovery, I should test it and take samples and to foresee and forecast what will be my design for the flow assurance system to prevent the problem before happening and to repair it or remove it or clean it after happening, right? So now we agree that we should care about flow assurance in the all phases, starting from discovery. We'll take every part, like 10 minutes for everyone, hydrate and paraffin, asphaltene, scale, and corrosion. Do you need to take some break now? It's okay for me. I can continue. If you want to take a break, it's okay. Adil? Sahar, do you have any idea to take a break or just to complete the session? Okay, I will complete. I didn't receive any answer, so I will complete. And if you have any question, just stop me. Okay, please continue. Okay. But don't hesitate to just stop me and intervene during the session and ask me any question you need. Okay. We talked that hydrate is a type of flow assurance that can be composed from water, from light natural gas molecules, mainly methane, maybe ethane, and with high pressure, not low pressure, as we saw in the assessment, and with low temperature. So this one will form a cage that hydrocarbon molecule, gas, is trapped in the water molecules, and it will be changed from the gas phase and water phase to be a solid, like this one. If you know that we have some unconventional reservoirs, and one type of them is called gas hydrate, and we have some hydrates like solid particles, and when you pump hydrate inhibitor or heat it, it will remove the water and the gas from each other and break the hydrate structure itself. So we'll start, as we mentioned, we have many phases in the stratified flow, gas, oil, and water. And we mentioned that not all of them will be pure gas, pure oil, and pure water. We have some mixed particles between all the phases. And with low pressure, with high pressure, and low temperature, this gas and water may interact with each other and form some hydrate particles. After some time, these hydrate particles get bigger in size, and they can block the flow line itself. Okay. So where the hydrate can form? We talked that it can form mainly for low temperature application, which will be subsea wells. We have a well, which is a subsea Christmas tree, that your Christmas tree is wet. It's now underwater and it's located above the seabed, and you are producing hydrocarbon, gas, oil, and water. Hydrate can be a mixture or a
Engineer Mohammed? I'm sorry for this issue. I will check Engineer Mohammed. I'm back, okay?
Okay.
Engineer Mohammed, are you with us? Hello?
Hello? I lost my connection, my internet connection. I will turn it back again.
Don't worry, okay.
Okay, I will reshare the presentation again.
Okay. Once you
What
share
is-
your screen, I will resume our recording, okay?
Okay.
Okay.
You see the slides now?
Yes, we can see.
Good. I will continue again. So we are producing hydrate mainly here for the subsea application. We have a subsea well and subsea flow line to reaching the platform. So during the past, during the journey of travel, I have some hydrate maybe after valve throttling or choke restriction, maybe for water accumulation, maybe for a riser or vertical parts. And this is actual foot of hydrate getting outside from picking trap. Okay. So what is the risk of hydrate? You have a solid in the flow line and you have flow, but you stopped the flow. So you'll have high pressure behind the hydrate plug and low pressure after it. When you have this high pressure and you inject some fluid to dissolve the hydrate or heat it to dissolve it, this hydrate is like a bullet, like a missile that can go very fast through the flow line. It can damage the flow line at the elbow section. It can damage the valve's mechanical parts. So you should take care about the hydrate, mainly for well intervention application. If you know that the PCE, pressure control equipment, like the lubricator, grease injection head, and risers, and all the stuff of the well intervention equipment for slick line and E-line, we have some leakage of gas. This gas leakage may introduce some cooling for the fluid and promote hydrate formation. And when you reduce the pressure or bleed pressure, this hydrate plug can move and can damage the equipment after it. Okay. How can I detect hydrate during production, not well intervention? By many methods. I can measure pressure and temperature in the flow line to see if there is high pressure reduction or temperature reduction that can promote hydrate or indicate the hydrate formation plug. And also I can detect it by many sensors, may depend on the ultrasonic detection or acoustic detection or density meters like gamma ray densitometer or any electric probes or fiber optic like DTS or DTS. DTS, distributed temperature sensing, and the distributed acoustic sensing. Okay, so we have many methods to detect the hydrate plug formation during production and through the flow line. So my mission here for this graph is that I have high temperature, and then when I reduce the temperature, I may face some hydrate. During the design phase, you will promote what is the design temperature and the design pressure that you will see during the production phase. Then by seeing the equilibrium phase, you see what is the subcooling temperature you need to override and to get outside this region. Because this region, you will have hydrate deposition. So I need to pump some methanol or ethanol or glycols or any hydrate inhibitor, maybe thermodynamic hydrate inhibitor or low dosage hydrate inhibitor. So to make this subcooling and prevent the hydrate formation. So we have hydrate plug, and when I pump or inject methanol and ethanol, it's called thermodynamic hydrate inhibitor. I will not see any hydrate in the flow line. But there are other category called low dosage hydrate inhibitor. It have two subcategories, kinetic hydrate inhibitor and anti-agglomerant. Kinetic hydrate inhibitor can delay the hydrate formation. So you have a short flow line, you can just inject this one with low dosage, low pumping or low dose. But thermodynamic hydrate inhibitor use a huge amount of chemical. But it's just a delay of hydrate inhibitor, of hydrate formation. Anti-agglomerant means that you have some hydrate particles like microcrystals without getting bigger and block the formation itself and block the flow line. We talked about heating and heat prevention. When we have some coating to prevent the heat losses, which is called the insulation, and we have some heating system by electricity that I have some cables around, heating cables around the flow line. I have internal flow lines that is have production fluid inside it, and I have some electric cables around it. When I use electricity in these cables, it will be heated and it will heat the flow line and the inner fluid itself. And also I have the internal pipeline and the external pipeline. I can inject hot fluid between both of them, right? Or can just have insulation between both of them. If I have insulation between the two pipes, it will be called dry. You have a question in the assessment that with insulation is between two pipes, which is wrong. With insulation means that with insulation is just around the external pipe and it's facing the environment. But dry insulation, it will be covered and protected by two pipes, and it's just in the annulus between them. And the schematic for bundle for subsea applications that you have some hydraulic oils, some electricity, some chemical injection, and some production fluids, and it's called umbilical. It's called SURF, subsea umbilical and riser and flow lines, that you have some applications or some other functions for the bundle itself. So as a wrap-up for the hydrate, I can remove hydrate or prevent hydrate by removing water, by gas dehydration or water cut reduction. Or I can use hydraulic methods. I told you that during startup and shutdown, I will have some problems of flow assurance. Mainly will be hydrate due to the low temperature. So you can just, when you have shutdown, you can just push your fluids to the formation and prevent the formation of hydrate or any other issues, and keep them in the hot region, downhole, not at the shallow depths with low temperature. Thermal methods may be by insulation, preventing heat losses, or by any heating systems that you can use. The chemical methods that you use ethanol, methanol, glycols, low dosage hydrate inhibitor, and salts to prevent or inhibit hydrate formation. But if you don't have any hydrate formation, it's okay, you can't do any action. The new topic will be paraffin. Paraffin is saturated alkanes or saturated hydrocarbons, which may be very long chains like normal paraffin or isoparaffin or cycloparaffin, but all of them are paraffin, saturated alkanes. It's a heavy molecular weight hydrocarbons that are dissolved in the hydrocarbon itself, in the crude oil, and due to temperature reduction, they get out of solution and deposit on the flow line. This is a pigging trap. At the end of the flow line, they use the pig to push the hydrocarbon deposits, and here it's mainly paraffin that can hinder the production fluid and prevent the flow rate maximizing. There are many theories about the deposition of paraffin, but the most famous one is diffusion, that you have layers of paraffin deposition on the pipe wall, and you have deposition of new ones, and they can diffuse inside the solid layer, and after some time it will be aged, it will be high density like condensed one, but it can deposit on the flow line wall or the tubing wall itself. And this slide is about actual compilation strings that get retrieved from the well, and can you see you have many deposition of paraffin and hydrocarbons that can restrict the flow of the fluid and prevent any well intervention job and going down through the well for perforation, for logging, for setting plugs, for any jobs downhole, like well intervention jobs. Okay, what makes paraffin deposition? It's mainly temperature. If you have low temperature, it will promote to reach the wax appearance temperature or pour point of the crude oil, and they make the solid get out of solution and be deposited on the flow line. And also some other issues that can promote paraffin deposition, maybe getting gas from out of solution, or having some roughness, some irregular surface or rough surface that can stick the fluids, stick the paraffin on it, and make their deposition be promoted. And also any injected fluids that can you inject them from the surface, they will have low temperature, so they can promote paraffin deposition. Asphaltene, it's different from paraffin, not the same topic. Asphaltene is not soluble in crude oil. Most of you answered this question wrong in the assessment before the seminar, that asphaltene is a soluble hydrocarbon component, which is a wrong information, that asphaltene is not soluble. Asphaltene is part of crude oil, but it's not soluble. It's like in colloidal phase, suspended, dispersed, and it's stabilized by some chemical hydrocarbons like resin that can stabilize them in the solution. When you remove resins or make pressure reduction, and this asphaltene particles, they can get to each other and they can form more asphaltene deposition and can deposit to the flow line. They are more harder than paraffin, and it's also more harder to clean them. You can use diesel for paraffin, but here you can use diesel, toluene, and xylene, and other chemicals to remove the asphaltene deposition in the flow line or formation or flow lines. Also, during well intervention, you may have some asphaltene or paraffin deposition inside the tool itself. It's a part of PLT, production logging tool equipment, that can hinder your operation and prevent the successful application or successful job. Can you see this structure of some asphaltene molecules? It's very, very complex compared with paraffin. Not straight chain, not paraffin. They are very complex and can be stabilized in the crude oil by resin. Do you have any question till now? Any contribution? Any inquiry? Okay. Scales. When you say scale, it means that you are talking about mineral scale. Mineral scale means that you have some ions that are dissolved in the water, and due to the favorable conditions of low pressure or high temperature or low pressure or mixing, any conditions that makes these dissolved ions get to each other and interact and to form a deposit. This deposit get out of solution and they make the asphaltene, the scale deposition. It's like the grain. We have a grain of the sandstone, and we have some, it's called quartz grains of sandstone formation, and we have some scales deposition between the grains itself. It's like crystals, like salt and sugar crystals, not like paraffin and asphaltene. It's now mineral one, not hydrocarbon one. We have many types of scales, depend on their cations and anions. Maybe sodium chloride, calcium carbonate, iron carbonate, iron oxide, especially for injector wells, iron sulfide, zinc sulfide, lead sulfide, calcium sulfate, strontium sulfate, barium sulfate. They differ, but how to dissolve them? You can dissolve them by water or by HCl or by other chemicals, maybe chelating agent like EDTA or DTPA, or biocides like THPS, but they have different structure. This is like the salt, the halide salt, and we have different composition of other scales. If you want to see actual pictures of them, you can see a pure scale, which is barium sulfate scale, and you have some mixtures, some layers of these scales may be combined with paraffin and asphaltene, and also you may see some irregular mixture and heterogeneous mixture of all scales and paraffin and asphaltene during production and for the production header. From these pictures, you can see the main restriction you saw from the flow line. How can you produce from this small area? It will produce more pressure losses and can affect your intervention capability and prevent any valve operation. If you need to close the valve, open the valve, control the choke, it will malfunction the equipment you are dealing with. So scales start with dissolved ions, and they have some ion pairing. They interact with each other and form a microcrystal, and this crystal will get bigger with time to reaching the scale deposit itself. What will make scale deposit? As you stated in the beginning of the session, it may be changing the conditions, maybe pressure reduction, temperature reduction, or pH reduction. When you reduce pressure, you will promote some scale deposition. But for temperature, when you reduce temperature, you will promote scale deposition for all types except calcium ones. For calcium carbonate, this is a question in the assessment. When you increase the temperature, you will promote scale deposition of calcium carbonate. If you are dealing with compilation or drilling fluids, when you inject some fluids containing some calcium bell or calcium carbonate fluids in the well itself, you are pumping it with low temperature from the surface. It will go down to the well downhole. When the temperature get higher, you will have some calcium carbonate scale deposition against the perforation. So most scales deposit when temperature go down, but calcium-based scales deposit when you have increase in the temperature. You can see some scales in the heater, your house heater in the bathroom. When you open it, or in the kettle, in the boiler, you have some white deposit. It's called calcium carbonate. When you increase the temperature and you have some calcium and the carbonate ions dissolved in the water, they will interact with each other and form calcium carbonate scale. Also for mixing for incompatible waters, that when you have some injection water, which is mainly seawater, not desulfated, it will contain sulfate ions, and you have some barium, strontium, and calcium ions inside the formation water. When you mix the formation water and the injection water, they will promote some scale deposition, especially sulfate. Sulfate deposition is very hard, and they called hard scales that should be removed by milling, maybe by cold tube or by EDTA, some special chemicals, as we stated, like DTPA or EDTA. Okay, this is the operation of mixing of some waters. I have high permeability streak in the formation, and I inject water from injector wells. And the injection water is going very fast through this streak. And during the production well, they will face some formation water. So they will interact with each other and form scales downhole at the bottom part of the compilation. It's called hard scales and mainly sulfate scales due to the water mixing. So how to monitor scale deposition? I can monitor the productivity index and production rate of the well. As we talked that we should test the well periodically to see if I have some problems of scale deposition or flow assurance issues or formation damage. If I lost some ions from the water, it means that these ions already interact with some ions downhole and produce some scale deposition downhole. If you have some injection water breakthrough, some companies, they measure the chloride of the production water, and when this chloride is changed, they will figure out that they have water breakthrough. And also they can figure out this phenomena by having PLT, production logging, to see that the injection water has just made some fingering or cooning or breakthrough and getting now produced with the production fluids. Okay, also for scales, I can detect the total suspended solids, not total dissolved solids. Means that you take a sample from the water and measure how many solids it can contain, called TSS, and to figure out what is the type of these solids, maybe sands, maybe scales, to detect if there is some scale deposition inside the well itself. Some companies use scale coupons. They have some coupons, very small metallic parts, have some pores inside it, some holes, and they put it in the flow line for some months, maybe 2 months, 5 months, 6 months, 1 year. And after this time, they take this coupon and see how many holes have been plugged. When you have all holes have been plugged, so it means you have high tendency of scale. Also, we have some sensors, as we mentioned for the hydrate. The sensors may depend on ultrasonic or acoustic waves or density measurement like gamma ray densitometer. So we have many methods to detect the scale and measure if scale happen or no. But also we have some physical sample taking, when you can have open the flow line or remove the flange or get inside the well with a gauge cutter or gauge ring or cool tube to collect the samples and to see what is the hard materials that you have in the flow line or in the pipeline that is hindering your production rate and affecting your operation by physical sample taking, sample gathering. So how to prevent scale? I should pump scale inhibitor. This scale inhibitor may be pumped through a macro tube. If you have a compilation, we have a bucker, and you can have a small tube that I can inject some scale inhibitor to mix with the fluid at the bottom part for getting inside the flow line. Also, I can inject some scale inhibitor with the gas if you are using gas lift, but not common. And this scale inhibitor will get inside the flow stream through the gas lift valves and prevent any scale deposition. But also you can use this pump, small pump, and to inject the scale inhibitor in the flow line itself. So I can inject continuously downhole or at the surface. But for the well, they can use squeeze job, bullheading, that you can inject the fluids inside the formation and make the scale inhibitor get adhere to the formation itself, and it can be produced with time. I have a spearhead or pre-flush that conditions the formation to receive the main treatment, and the main treatment contains the scale inhibitor that will be stored in the formation. And the overflush is like a displacement of the fluid to far away area with low velocity of flow that will affect the chemical desorption. You have two phenomena: chemical adsorption that can be stick to the formation, and the chemical desorption, it can be now produced with the fluid and prevent any scale deposition during production. My last topic, inshallah, will be corrosion. Do you know corrosion? Yes, we all know corrosion. Corrosion is interaction between the metallic parts and oxygen and water. So it means that I have some oxidation of the metallic component, and it leads to deterioration, damage to the flow line or the metallic part. Can we see it? Yes, we have anode and cathode. Anode means that we have iron that gives electrons, and it will be dissolved in the fluid as an ion. So I am now losing iron here. But here we have 2 electrons get through the pipeline, and these electrons can interact with hydrogen and oxygen and produce water or produce OH, hydroxide ions. So I am now losing ions, iron ions in the anode, and it will be deteriorated for the flow line itself. So it's a simple mechanism of corrosion. But corrosion in the industry have many types. Maybe uniform corrosion, that you have corrosion interaction to all the parts of the metal itself. Maybe pitting, that you have some coatings that prevent corrosion, but this coating is for stainless steel mainly, get jeopardized by chlorine and have some metallic attack to this bit and increase the corrosion for a small bits. It's called localized corrosion. And we have many other types of localized corrosion, maybe crevice and intergranular. It's similarly, as we talked, that we have an alloy. Alloy means that you have different metals that make and combine to make your metal. But you have problems in the boundary between the alloys itself, and this is a localized corrosion. Galvanic corrosion means that you have different metals. One of them will act as an anode, and one will be like a cathode. So the anode will be deteriorated. So it's mandatory if you are using a compilation not to use many alloys in the compilation itself. Different metals. You should use very similar metals or the same ones. Erosion corrosions means that this is for impeller for a pump, that corrosion and erosion are now combined to deteriorate the metal due to the aggressive act of chemicals and solids and the sand. Selective leaching, you have an alloy and some element of this alloy may be zinc that taken and this be stolen from this alloy to be dissolved in the water itself. So it's like a selective leaching, selective taking from the ions, but eventually it will affect the integrity of the metallic part or metallic component you have. Stress corrosion cracking, we have some high pressure gases, especially H2S, that can get inside the metallic parts and they make corrosion and cracking also for this metallic component, especially for turbines. If you are using turbines with high pressure gases containing H2S. Cavitation corrosion, especially for the pumps. When you know this type, you have some bubbles, gas bubbles, and these gas bubbles get exploded at the surface of the metallic component, the impeller. That can make some cavitation, some heating, and the impact affected to the metal to damage it. The last one is hydrogen embrittlement, that you have some hydrogen gas that get inside the metal in the pores itself and at high pressure. And when you reduce pressure, this hydrogen gas can expand and it can damage the metal part itself. So it's like many parts, many mechanisms of corrosion combined with other ones like corrosion and the erosion and gas expansion. To how to prevent corrosion? At the beginning, I should not use any corrosive fluids. It's okay. If it's mandatory to use them or your fluids is corrosive, I can use corrosion resistance alloy. Good. You can use coating inside the flow line or inside the tubing itself to prevent the interaction between the corrosive fluids and the metallic parts. Good one. But all of these one are for the internal corrosion. For external corrosion, for wells, you know that casing had some cement around it. This cement should be good bond to the casing and covering the casing from all the directions to prevent the interaction between the aquifer water to the casing itself and they make outside corrosion. And for static parts like above the bucker, you can use some inhibited completion fluids with inhibitors to prevent the corrosion. And for the big facilities like pipelines, offshore platform, and the tanks, you should use cathodic protection. If you know this one, you just use a sacrificial anode or embraced current technology that you prevent the corrosion of the main structure and promote the corrosion for the anode. Maybe like a rod immersed in the ground, and after some time you can change it with a new one. Okay, this is for the corrosion resistance alloy. It may be chrome 13, chrome 9, maybe duplex, maybe nickel-based alloy for the metallic parts, the tubing or the completion. Or you can use some cladding, some coating, internal coating to prevent the corrosion. This cladding may be corrosion resistance alloy or maybe plastic parts or thermoplastic material. Also, you can use chemical treatment to prevent the corrosion by using scavenger like oxygen scavenger, H2O scavenger, pH agent to increase the pH and make the fluid basic, not acidic, because acidic promote corrosion. Do you have any question? I think I talked many times, so I am now going fast through the slides. If you have any question, just stop me. Okay, I didn't receive any response, so I assume you are okay till now. How to monitor corrosion? For surface facilities, we use corrosion coupon. This is like the same material of the flow line. You put it inside a chamber in the flow line, and after some time you retrieve it to see what what is the weight it has lost during the production itself. It will lose weight because due to corrosion, right? And these holes, if you remember, may be used for scale coupon. If you have some plugging for these holes, it means that you have some scale deposition, right? And this is ultrasonic sensor that can be used for critical parts like the elbow, because the elbow here mainly will see some impingement and hitting and impact of the solid particles in the elbow itself due to solid production and sand production. The most common for the industry is UT inspection, ultrasonic inspection. Some service companies get to the flow line and to see the can be used for corrosion evaluation, for internal and external corrosion for the flow line itself, especially for inaccessible flow lines. Okay. For downhole corrosion, we have some logging tools, maybe multi-finger caliper log that have many mechanical arms that can go in and out to measure the internal diameter of the tubing or casing. And we have many other methods that can determine the thickness of the casing itself or the tubing, like ultrasonic, electromagnetic, magnetic, noise detection, and the camera recording to see if I have some leak inside the flow line or inside for the tubing or for the casing itself for downhole application. Okay, do you have any question? Okay, the last part will be the remedial action of flow assurance issues. Do you know what remedial actions you should propose to prevent this flow assurance challenges? Hello, guys. I already mentioned all of them during the session, but it's like a revision. So we have some operational practices and technologies for prevention that I have can use insulation, heating, right? Pressure support to prevent the pressure drop, avoid incompatible water mixing, and separation of water from gas to prevent hydrate and from oil to prevent corrosion and prevent emulsion, and also internal coatings, maybe plastic or corrosion resistance alloys, and maybe use tubing or casing itself as a corrosion resistance alloy, and chemical inhibitor to prevent the hydrate or prevent the scale or prevent the paraffin or asphaltene, maybe by squeeze in the formation or maybe continuous injection, maybe surface or downhole, and some non-chemical inhibition like using magnetic and the electromagnetic waves. It's a new trend now, new technology in the industry to prevent the scale deposition. And the chemical remover, if you have some problems that happen and deposited, you should remove them. For scales, I can use water for halite and acids for acid-soluble scales or creating agents for hard scales. And for paraffin and asphaltene, I can use diesel, xylene, toluene, and other chemicals, specialized one. And for removal, I can use coil tube, I can use slick line, and I can use scratching or pigging for surface pipelines. It's okay. And also for the workover, if you have a completely plugged compilation and you can't retrieve it and you can't clean it or dissolve it by mechanical or chemical reaction, you should retrieve the compilation and change it. Thank you for your time. I hope this session was beneficial for you and you have enjoyed it. And if you have any question, I will wait for it. But before the question, we can return back again to the assessment to see our questions. Okay? It's like a wrap-up of the session and to see what you have answered right or wrong. I don't know your answers. I just see the answer as you saw, like a cumulative one. Do you see? Can you see now the assessment? Adil, Sahar?
Yes, yes, engineer.
Ahmed, I see it. I saw it.
Good, good. If you can open the link again, or just to see with me, you can open the link if you want. But for us, I need some volunteers to answer the questions, to see the question have been answered right or wrong. Who will volunteer for the first question?
Yeah, this is true. Agree 100%. And we discussed, yeah, you discussed this in the beginning.
You agree 100%?
I mean, the hydrate, it will happen when you have water with the hydrocarbon, and there will be a temperature reduction, but there is no temperature mentioned here. But so we will be disagreeing.
Disagree. Good. Because we have low pressure, not low temperature, right?
Yeah, correct.
If it is low temperature, it will be 100% right.
Yes. This is what
But-
I meant. Yeah.
Good. But mainly will be don't agree, right? Or some guys may accept agree with some remarks and say it's okay, we should have some water and hydrocarbon gas, but not high pressure, not low pressure. It will be high pressure and low temperature, right? Good. For the second question, I need a volunteer. Another one. Ibrahim, can you answer this question?
Hello, yes.
Yes, sir. Rickard, we are listening. Yeah. Can you read it and
Yes.
see if it is right or wrong?
It's wrong. It's non-soluble.
Good, mashallah, mashallah. It's non-soluble. I need another volunteer. Guys, can anyone participate in this question? Maybe Fatima, can you read this question?
Paraffin dispersant works by depressing the wax appearance temperature. Honestly, I don't have any comment, but it may be 100% true.
And you are right, I didn't mention this during the session. I didn't talk about the paraffin dispersant. By the name, dispersant means that it contains the system or the wax as a droplets, not
Okay.
by reducing the wax appearance temperature. The chemicals that reduce the wax appearance temperature is called wax modifier or wax inhibitor or pour point depressant. So
Okay.
this answer will be wrong.
Yes.
Because paraffin
Do not.
dispersant
Okay.
not accurate. We'll keep the hydrocarbon, will keep the wax as a small droplets, not depressing the wax appearance temperature.
Thank you, engineer.
Thank you. For the fourth question, do you have a volunteer? Maybe Hussein? Maybe Luis? Or any guy that he want to contribute or answer the question? Yes. Don't be shy. You can just contribute with us, maybe by saying any words, maybe right, maybe wrong. But the target here is to hear you and make your contribution.
What insulation for the pipeline should be placed between two pipes for efficient thermal management?
Yes. Do you agree or don't agree?
Agree with some remarks or 100% agreement?
Okay, I told you that we have two types of insulation, mainly two types.
Two types.
It's actually many types, like 5 or 6, but the most common types, wet and dry. Wet insulation means that the insulation is facing the environment. It's just coating the outer side pipeline. But dry insulation means that you have insulation between two pipes in the annulus between them.
And it is wrong.
So it's wrong, yeah.
It's wrong. Yes.
Other types of insulation may be bundle insulation, or maybe vacuum insulation, maybe change phase insulation, many types. But the most common will be pipe in pipe, which is called dry and wet insulation. Okay,
Thank you, engineer. Yes, got it.
thank you, Fatima. Do you have another additional volunteer? We have many guys here in the session. We are now like 21. Mahmoud Yasser. Adil, are you still with us? Adil from OBA. Zakaria? Okay, do you have any volunteer? Can anybody say hello? I can read the question and answer it. It's pretty easy.
May I?
Yeah, yes.
Yeah.
Just go ahead.
Carbonate scales will deposit when temperature decreases.
Yeah, what do you think?
I think it is true.
I don't know.
When temperature increases?
All scales, most scales will deposit when temperature decrease.
But الكربونate scales
good.
يعني
when temperature increase.
Increase يعني do not agree.
Don't agree. Good.
Yes.
I told you an example for the completion fluids during workover and the completion activities when they use completion fluid based on calcium pill or calcium carbonate particles. They pump this fluid inside the formation. They will have some scales deposition due to the high temperature increase. And
Yes.
also for the heaters that we have in our bathroom and the household applications, you have some scales inside it. It's called calcium carbonate. And also for the tea boiler and the kettle, you have some white deposit inside it. It's mainly calcium carbonate. For number 6, go ahead, Fatima.
Okay. Scale deposition affinity is not affected by the application of any hydrate chemical inhibitors.
Yes, what do you think?
I think it is right.
Right? It's very advanced question.
One second.
It's very advanced. We have two issues here. We have scale deposition and we have hydrate. To prevent hydrate, I inject hydrate inhibitor,
Hydrate, no.
which is mainly methanol, glycols, or ethanol, and other types low dosage hydrate inhibitor. But for scale deposition, when I inject hydrate inhibitor, it will promote scale deposition.
Okay.
You are curing and dealing with hydrate inhibitor, but at the other side, you are promoting more scale deposition.
Yes, it is wrong.
Yeah.
Okay.
We still have two questions. Gas lift completions promote emulsion formation and scale deposition. I told you that scale and emulsion can be promoted by gas lift because mixing and agitation of the gas, and especially scale when gas get outside from the gas lift valve, it can expand due to Joule-Thomson effect. The temperature will go down and some scales will deposit. For number 8, you already answered this question right. smart or intelligent pigs can inspect the pipeline wall thickness for corrosion monitoring purposes, for inaccessible flow lines that can you inspect them manually from the surface, like subsea flow lines and buried flow lines. Okay. If you want to contribute this assessment, what's your opinion about the session content itself? You can open the link from the chat box, right? But till now, it's okay for me. Sahar, Adil?
Yes, Engineer Muhammad, I'm here.
Yeah, I'm done till now. I have completed the session. If you can receive any question or just wrap up the session, it's okay.
Sure. Can I stop recording now?
Yeah, it's okay.
Okay. Okay, Engineer Muhammad, thanks for your time and for your effort. Yani it's a great session, really.
Thank you. It's a pleasure.
Thanks for your effort, really. Thank you all for attending this session today with us. And I mentioned the feedback form in the chat box. Please take 2 minutes to fill it, please. And a certificate will be generated automatically on our website tomorrow, inshallah. Okay, we have just 2 minutes, Engineer Muhammad, to fill the feedback form. If you have done, please write to me in the chat box that you have done. Thank you, Engineer Fatima. Thanks.
Fatima is very active. Mashallah.
Sorry, Engineer Muhammad?
I'm saying that Fatima is very active.
Yes, yes, yes. Thank you, Engineer Haider.
Mashallah.
Engineer Muhammad, thank you. Engineer Masoom, thank you. If you have any inquiry before we close our session, please feel free to put it in our chat box. Yes, it was an amazing session, really. Yes. Engineer Muhammad, thanks for your time, really. It's our honor to have you in our session, in our course, inshallah. Thank you all. It's my pleasure to see you again, inshallah. Thank you.
Inshallah. Thank you, sir. Thank you all. Thank you all for your time. Have a good day or have a good night.
Thank you, Muhammad, for your time.
Thank you. Thank you. It's a pleasure. Thank you.
See you in the next course, inshallah. Thank you all. Bye-bye.